Hello everyone and welcome back to Python lectures. Today we are going to start how we can actually make code of various sorting algorithms in Python. So the first algorithm that we are going to see is of insertion sort. So here in this video, first of all, I will be taking an example of insertion sort and explaining how it works, and then we are going to shift towards the programming part, right? So first, let us understand what do we understand by the insertion sort with its introduction. See, insertion sort is a very important and very trivial, sorting algorithm, which is based on the way we sort our playing cards, right? So I have a deck of card, right, that is placed on the table, and I'm supposed to pick one card, right? Now say the first card that I picked, right, that is 5, right? And I just hold it in my second hand, right? So with one hand, I am taking out the cards from the deck and then putting it in our next hand, right? So let's say the first card is 5 and I placed it in my hand. Now I have only one card in my hand and I do not need to compare it with any other card because one single card is already sorted. Now compare this with the list of element. A single element is already sorted, right? So if I give you a number 5 and say, okay, sort 5, you will be saying that 5 is a single number and it is sorted, right? So now I have only one card in my hand, that is 5, right? Now I am putting out another card from the deck, right? Let's say the next card is 4. 4, I will be comparing it with 5. I have one card which is 5 in my hand and now I have taken out 4. Now 4 will be compared with 5 and I know that 4 is smaller, so I am going to keep it in the left hand side of 5. So you can see that over here, if 5 is my first number and then 4 is my second number, I will be placing 4 over here if it is the second number, right? Now suppose the next card that I drawn is 10, right? Let's suppose I have taken 10 out of the deck, right? Now what is I am going to do is I will be comparing 10 with the cards which are in my left hand, that is 5 and 4, right? So let us just take it like this, that the cards that I'm holding on my hand are already sorted, right? And the card which I'm taking out from the deck has to be stored in a position so that the cards that are already in my hand remain in the sorted position. So the next card is 10 and now I am going to compare it with 5 then 4, right? So this the comparison will be from the right hand side. So this 10 will be compared with 5, right? And I know that 10 is greater than 5, so it should come on the right hand side and there is no need to compare 10 with 4. Similarly, let's say the next card is 2. Now here 2 will be compared from the right hand side. The comparison is always from the right hand side in the insertion sort, right? So 2 will be compared with 10. Okay, it's less. Then I'm going to go to 5. Okay, 2 is less. Then I will be comparing it with 4. Okay, 2 is less. And there is no other card over here. So I placed 2 at this position. Now let's say the fifth card that I have drawn is 7, right? So I will be start comparing it from the right hand side. So 7 will be compared with 10. Okay, 7 is smaller, so I'm going to the left hand side. Then 7 is compared with 5. Okay, 7 is greater. So now I know the position that 7 should lie in between 5 and 10. Now that is the way of doing insertion sort. We are inserting a new number or a new card on its correct position, right? And here we have divided our list or our cards into two portions. One is the unsorted and another is sorted, right? So sorted is which we are holding in our hand, and unsorted is the number that is we are drawing one number from the unsorted list, which is the deck of the card. So here is the example in with the help of an array or a list. Now let us see this in detail, right? So these are the list, which is of course unsorted numbers, and now what I want to do is to sort these numbers with the help of insertion sort. right? So suppose that this is the deck of card and one by one I am taking out numbers, right? So let us say the first number is 9, right? So this is my deck of card and the first card that I pulled out is 9, right? So 9 I will be holding in my left hand, right? In my next hand. With one hand, I will be taking out the number, and with the second hand, I will be holding these number, right? So now we have started, the division. So 9 is a single number, and single number is trivially sorted. So I do not need any comparison. So what I did, I hold 9 in my hand as it is because there is no other card for comparison, right? So now from which section comparison started? Comparison will be started with this particular section, right? Now this is the first number. I do not need to compare this with anyone, right? So in my hand I am holding 9 and now I will be start comparing. Now the next number which I need to pull out from my deck is 2. So 9 I am holding, and the color which is marked as red is the newly taken card from the deck. Now this is my key. I will be calling it key in this particular example, right? So key is 2. Now I have only one number, that is 9, with which I need to compare 2. This is 2. So I need to compare it with the elements which are backside. So move it from there and just compare it with 9, right? I'm just comparing. It is very evident that 2 is less than 9. Then shift 9 to that place and make a space for 2 and place 2 over here. Now these two numbers are sorted. So 2 and 9 are now in sorted order. There is no contradiction in it. So again you can see that the array is divided into two portions. The yellow one is the sorted and the blue one is unsorted. Now the next key. Again take out the new number which will be 7 this time, right? And now where will be the comparison? Comparison will be from this portion, that is from right to left, right? So first 7 will be taken out and then compared with 9. Yes, 9 is greater. So 7 should be in the left hand side, right? So shift 9, right? But yes, there is two numbers, right? So now 7 will be compared with 2 also, right? Now 7 is greater. Now it is evident that it belongs in the middle portion. So place 7 over here and now you can see that these three numbers are sorted. Now the new card, that will be 5. So key is 5. Again the comparison will be with 9. Yes, 9 should be shifted and you can see that 7 is also been shifted and 5 belongs to this position. Place 5 over here and now these four numbers are sorted. Again the next number will be 1, right? Now 1 will be again compared with 9. Yes, we need to shift it. Yes, 7 we need to shift it. 5, yes, 1 is less than 5 and 1 is also less than 2. Shift it and you get the position for card number 1 or the element number 1. Now similarly we are going for 4. 4 will be compared with 9, 7 and 5, and when it is compared with 2 we got the correct position. Now this is sorted. Similarly for 3, now 3 will be compared with each and every element, and after 4 when it is compared with 2 you got the correct position of 3. And similarly for 6 you can see 9, 7, and when compared with 5 you know that 6 is greater and you got it correct position. And now this is our sorted list. So I hope that by now how we are actually working with insertion sort is very much clear to you. So we are dividing our list into two portions, right? The sorted portion will be remain sorted because as the name suggests, we are going to insert the key, that is each element which are drawing from the unsorted portion. We are going to insert it at the correct position only. That is why the name of this sorting algorithm is insertion sort. So now let us move to Python Visual Studio and let us see how we can make a program for insertion sort. So here in order to make a program of insertion sort, I will be making use of functions and I will be making a function with the name of insertion sort. And you know that here in Python we are performing sorting on list. So I will be giving a list as the input to my function, right? So the unsorted list is this list, and with this function, what is this function is going to do? This function is going to sort this particular unsorted list with the logic of insertion sort, right? So let us see. For I in range. Now remember, here I am making use of a for loop. Why? Because in insertion sort, the first number is sorted, 9 was in our example, and the rest of the list I am taking out one number, you know, in a sequence. Every time I take a new number, which is my key, from the unsorted portion, right? So remember, the first index, that is 0, the indexing in list starts from 0. So 0 is trivially sorted, 9 was already sorted, the first number is sorted. So the comparison starts from the number 1. The 0th index is sorted and the first index is not sorted. So here I will be starting the range with 1 and it will be going till length of my list, right? So this will be from the second number of my list till the end of my list. So that will be my for loop. So every single time I is going to take one number from that list, right? Now I is the index value, right? So I need a variable to hold the value from the list, right? So what I is the first index, so key will be the first element, the element at the first index, right? So 0 is trivially sorted. So what I did, I make the next number in my example, right? The first number was 9, so 9 was at 0th index. The second number was 2, so 2 is at 1 index, right? So I have taken the index 1, that is I in the first iteration is 1, that is the index, and the element that is present at that index is 2. Now 2 is getting into this key value, right? So now this is the number that we are actually taking from the unsorted list every single time. Now the next thing is I need to perform the comparison from the right hand side to the left hand side, right? Because you can also remember or pause the video and see the example again where we are comparing from right to left from our sorted list, right? So I need an index for that, in order to keep tracking of that. Okay, the leftmost number, then okay, coming back to the left one, then coming back to the left one. So I need the index, so I will be placing a value that is like this. Here let me just also make it as an example so that you can understand. Suppose the number was 9, let's say 2, let's say 7, let's say 5, let's say 3 or 1, maybe a random number, right? So these are my numbers. Coming over here, now this is my index. So it is at 0th index, this is as 1 index, 2, 3, 4, 5 and so on. Now this is my index, right? So here the comparison will start from here. So I have taken 1 till the next time, right? Now the first element which is at this index is now my key. So 2 is in my key. Now what I need is, I need to compare, if you want to see that, I need to compare this 2 with 9, right? Now 2 is at 1 index, right? So I have taken a value as j, right? Now j is equal to I. In the first iteration, I is 1, right? 1 minus 1, which is equal to 0. So where I did actually place this j, I placed this j over here, right? Because I need this 2 to get compared with 9. That is the extreme, the immediate left number, right? In the further examples, in the further iterations, actually, when this value of I becomes 2, right, then the comparison will be from the immediate left one, right? So j will be equal to 1 and this will be a decreasing loop from 1 0, then from 2 1 0. So that will be going from right to left in the decreasing order. So I just placed j at the immediate left one, the immediate left index of key, right? Now what I need to make a decreasing loop. So while j is greater than equal to 0 and, right, because I need to compare it till the end, right? And remember, I'm not using or over here, I'm using and, because this is the main condition. and the key should be less than the element which is present at the index of j, right? So what I'm going to do over here is I am comparing 2 with 9, right? And if, when the shifting will be done, only when 9 is greater than 2, or vice versa, 2 is less than the element which is at jth index, then we need to perform the shifting, right? And how we are going to shift this? We are going to shift this like this. So list j plus 1, right? We are making room for the shifting, is equal to list j, right? And then because it's a while loop and I want it to be a decreasing loop from left to right, so j will be equal to j minus 1, right? So for example, if I have a number 7, then 7 will be compared with 2, then of course something will be, the number will be either less or more, and then we are going from the right to the left portion. So this is the decreasing while loop. Now I will be coming out of the while loop, and the list that will be again the swapping one portion is this, and then place at this position your key. Now if that is the situation, then put key at the correct position. Now that's all. Now this is the simplest example of insertion sort we have done with the complete portion, and let us say run this with some examples. So let's say the number shall be anything of your choice you can place. Let's say this is unsorted list over here, and again I will be calling insertion sort, or let me just print it uh, unsorted list, right? And print list over here. After that, let us call insertion sort on list only, and here just copy these two lines and paste it like this, and in place of unsorted make it as sorted list. Now this is my driver code. So let us run the code and see what we got as the answer. And yes, now the list is sorted. So you can see that with this particular, logic of insertion sort, we got the answer of my sorted list over here. So that was a simple code. You can also note it down. This is a simple code of insertion sort in Python. Now I hope that you understood the working of insertion sort, and for more such videos on Python, stay tuned to my channel. Thank you.